Hello guys, welcome back to my channel. So today we will be discussing about the flattening of binary tree. But what's the special is I will try to solve this using a Morris Traversal. So while I was going with the Morris Traversal technique, I found that it can also be solved using that thing, using that intuition. And I thought it would be good if I try to share with you people also. At first, it might seem a bit confusing, but uh, here you can see how it is solving solving step by step into a sub problems. This algorithm, and it is also an efficient thing because it solves an often and of one of a space complexity and often of time complexity. Okay, let's go through the question at first. So the thing is, we are given a root of a binary tree, and we need to flatten the tree into a linked list, where they are meant by the linked list is uh, all the tree nodes. So class we need to use the same class as tree node to this itself, where the right child of the points to the next node in the list and the left child pointer is always null. So they want to say that put all the left for all the nodes, put the left pointer that is left pointer as null and right pointer as a next of consider it as a linked list next node. Okay. So we need to align all the nodes towards the right side, and it should be a linked list, and which follows the pre-order traversal. So how do I wanna do this thing using Morris Traversal? So while I was going through the Morris Traversal, I tried to solve it for how to print it for the pre-order. So what the intuition is, so let's go to the board and see how it is. So let us take an example. I will try to say you that please try to make sure to beforehand learn the Morris traversal, or in the next video I will try to keep it in. So here I will try to just give a summary, and let's understand the function. So for example, what happens in a Morris traversal is if we have an example, we have a tree like this, binary tree. Then in the traversal part, what we will do is we will take from the current node, we would consider the left subtree and go through its rightmost node, which is not null, and then create a thread that is a type of, we could say, an attachment or a thread, we could say, towards the this root. So due to which uh, we will be having a pointer of current and previous over here, and using this same concept, since we having two pointers over here and here, I would try to convert it into a linear thing, something what we are desiring to do. Okay, this is none, this is none, this is none. So let's understand with a much bigger example. For example, we are having something like this one, 5, 6, and 7. Now, the algorithm starts, as you know, Morris Traversal. The algorithm starts with a current over the root. Then we will consider the left subtree and go over and see, is there, go to the rightmost not null node in the left subtree. So I will go from here, and I have seen this is the not null last node. So what I will do is I will make a thread over here towards the current. Okay, now what's with this thing? Let's understand step by step. So in that algorithm, what I will do after making the thread, I will move my current over here. Okay, then the same algorithm repeats. Now it says, okay, again for this root node, try to uh, go to the left subtree, that is this one. Okay, and search for the rightmost not null node, which is this one. Now I will make a thread again over here. Now How I'm doing this search, it is using with another previous node as a pointer, which is able to find the rightmost ordinal node in the left subtree. Okay, let's consider it as a P. Okay, so let's rename. Okay, now the thread has been made, and my current now switches from here to here. That is this one. Now again, same algorithm. Now since I don't have any left subtree because it's null, my current will go to right side. And actually, what is the thread we are making? It's actually the current node's right part itself. Uh, that is the nodes dot right is equals to that true. Okay. So this is what we are made. So the threads we are making is the right part. Okay. You can understand that it's a right pointer of that. No. Okay. So what we will do, we will move our current to here again. Now, again, the same algorithm repeats. It says go and search in the leftmost row. So when we try to go, we will try to make a left like a previous pointer. And now this previous pointer tries to search the rightmost not null node in the left subtree. Okay. Now it goes and sees uh, the previous dot right itself is pointing to the current. Now we need to stop at this point. Okay. So at this point we have discovered that P dot right is equals to current. Now what we have to do? So in this situation, we are having two nodes. It is one node at the root and another node at this point. Okay. Like this is previous. So what I will be doing is I will try to flatten it by simply uh, by intuition we could see now I try to break this right part and I would try to put it towards the left node right node of the current. So what I will do is P dot right is equals to current dot right. Okay. Then I need to put the current dot right towards the previous pointer. So current dot right is equals to previous. So it's just something by intuition I am making the flattening part and it's not anything complicated. So after that I have made my go towards this thing and to clean up current dot left should be equal to null. That is this node will be one and now it will be pointing towards null. So at last we want to be able to see. That is now the things have became something like from this one, it has been converted to 2 towards 3 and 3 towards 4. So this is actually the flattening part. So now our total tree looks something like this. Here it would be 2, then it would be 3, and it would be 4. Okay. And this one would be 5, this one would be 6, and this one would be 7. The threading part which we have previously done for the fourth node, this one is still present. Okay. Now what we will do? The next part after making it flatten is to move our current pointer to previous dot right. Why? Our previous was here before and our current was here. So we need to proceed for the next one. So now I will try to push my current over here. Okay. Then the same algorithm goes on. It says there is no left node. So there is no left subtree. So it goes towards the current dot right. That is current dot right is towards one. Now the same algorithm repeats. And now again, when I make a previous over the left subtree over here, uh, left subtree, where the previous will go and sees this is this previous, that is this previous dot right is equal to the current. So what I will do, the same part, that is again the same algorithm repeats. When I will meet this condition, that is I will put previous dot right would be current dot right, that is this one, that is current dot right, and this linkage would be removed. And then I would be creating current dot right is equals to current dot left. So this one by intuition. Now this linkage would be removed. Then after I will try to remove this one. So by current dot left is equals to null. So this would be null. And that's how I have made the things now flattened. That is now it has become 1, 2, 3, 4. Now you can observe that the left part of every node has become null, while the right they have been flattened to the next node in the pre-order as a pre-order traversal. Okay. So now this one points to here and this one to here, fifth node and this one 6 and this one 7. Okay. So previously where is our previous node, that is at the fourth node. Okay. And uh, and our current was at this point. Okay. Now what I will do, I will do previous node right. So current now is equals to previous node right. So it will move to here, which is no left node. So it will traverse over here, which is sixth node. Now it sees this is the left node and makes a thread like this. And now again the same thing. It moves here. It sees no left part, left subtree. It goes again over here, sixth node. Then it says, hey, my previous, that is, in order to find the rightmost not null node in the left subtree, I found that it is having a thread to my current. So what we will do? Let's consider this is a null. Now we'll do a bondage something like this and remove this one to null. So everything becomes flattened now. So this is how I try to learn. Now let's put it up. I think I have made my explanation too tough. Let's understand it by code. And this is my first video in explaining algorithms. So I felt a bit of nervous. Let's go with the code. So what I will do, I will make a temporary node that is current. Okay. Which would be first I will try to assign with a root. Then let's do a while loop. So it's basically following the same algorithm code pattern of Morris Traversal itself. So we could see a similar pattern there. Just a small bit of modification is needed here. For example, now if current dot left, I see current of left is not null, or if it is null, what we will do? Then we would our current wouldn't go towards right side. That's the easier. Now, what if left chapter is not null? Then let's make a previous node. Why? Which is at the current dot left. And now, since we are at the current dot left, that is the root of the left subtree. Now let's find the rightmost not null node. So what is the condition for that? So it's simple. It goes something like previous not right. If it is not equal to null, then continue. Previous not right. Sorry. Previous is equal to previous not right. But there is a catch. We have also need to stop for when the previous not right is equal to current. So I need to put something like it is also equal to correct. Okay. So now there is a two conditions. So this is if previous dot right is equal to null. Okay. This is the way the threading part happens. So what we need to do? We need to put previous dot right. So try to visualize. For example, here we have reached the left part. Now reached the right part of the left subtree. Now I need to make the thread. What I will do? This is my current. Remember. So I will do previous dot right is equal to current. Then after, it's important to move my current pointer towards left side as per the algorithm itself. So current is equals to current dot left. Okay. So now my current will go here. That's it. What if I see that thread is already present? That is a previous dot right is equal to current. Then what we need to do? We need to remove the thread, or we could say reorder and flatten. So simply what I will do now, I will put my algorithm over there. For example, consider there is a thread and we have detected the thread. So what we will do, we will first point out this previous towards the current dot right. So previous dot right would be my current dot right. Then uh, I need to point over this node towards this one. That is current dot right. It might seem a bit of difficult, but it's just I am trying to find out a pattern, okay, that matches. The main advantage over this algorithm is I'm having two pointers at different locations and I'm having three nodes. So I could likely easily do a rearrangement itself, like we have learned this part in linked list. So okay, now the current node right becomes current node left. This is the important point. And after that, current dot left should be made to null, or we might see some irregularities over there. Cleaning up is important. After this, it is most important. Now, until here, everything is sorted, but we need to move our current pointer also, right? So our current pointer now moves to previous dot right. Now you might ask, how did I find its exactly previous dot right? Here you can observe. Until now, if I'm trying to solve this part, we already know that left side is already being flattened. So now we are trying to flatten over this part. Okay, so the first we have gone to the left subtree, flattened it. Now we are at the root and we are flattening, trying to flatten it. Then we are trying to go to the right side and then we are going to flatten it. So why does this algorithm works? Now since we are only left with the right side part, so we need to go for it. Okay, that's it. So we will go here and always try to remember that is pre-order means first we need to print out our root, then our left, then our right. Okay. So what we are doing is we are trying to sort of flatten the left side, then the root, then the right part. So this is how this algorithm works. And surely I would consider everything is right. Let's try to run this one. Okay, I got semicolon error as a coder. Now let's try to rerun loading the logic. I didn't think so. Yeah, everything has been accepted. Now let's try to summon this one. Yeah, everything will work there. So that's all for now. Thank you, and share your views regarding this and how I need to improve my explanation skills also. Thank you.